Thinking tonight. I'm Matt, the host for tonight's Hangout on Air, and I'm one of the GEG NZ leaders here in New Zealand, and I'm also the director of the Mind Lab in Wellington. We do a little bit of computational thinking stuff at the Mind Lab with coding and robotics, but the people that I've got talking tonight are Jedi Masters at computational thinking. So without further ado, I'll introduce the awesome peeps we have with us tonight. So we've got Sallyann Williams, who's the Engineering Community and Outreach Manager for Google. Hi, Sally.
Hey!
We've got Dr. Rebecca Vivian from CSER in Adelaide. She's the Research Academic for Computer Science and Education Research Group. Hi, Rebecca.
Hi.
We've got Meridith Ebbs, who's the e-learning specialist and innovation integrator at St Columba Anglican School in Port Macquarie, and she also works with PEIC, the Professional Excellence and Innovation Centre, and does some great work there. Hi, Meridith.
Hi, everyone.
And we've also got James Robson, the ICT specialist teacher from Forrest Hill School in Auckland. How are you, James?
I'm good, thanks.
So, these guys have all got various experience working with computational thinking and doing some great and exciting stuff. So I thought rather than me talk for any longer, I'd hand over to these guys to have a bit of a talk about their area of expertise and answer particular questions we've got. If anything the guys say tonight is of interest to you and you'd like to follow up with some notes or resources from the session, everything will be posted in the event description for tonight's session. So I'll hand over to Sallyann and start with this question, Sally. What is computational thinking and why is it important in education?
Awesome. Well, thanks, Matt. So I'll start with, I guess, one of the things that I'd like to address first of all, is computational thinking sounds horrifically scary and terrifying, especially, I think, when you're talking to teachers who are not from an ICT background or a technical background, and they think that it's bigger and scarier and more technical than what it really is. At its base level, at its core level, it's really just problem solving. And that's made up of four main sort of components. Decomposition, another big sort of scary word, which really means breaking down a problem into bite-sized pieces, which is pretty simple to do and has a large range of sort of ways that happens. Pattern recognition, self-evident, sort of self-explanatory. Abstraction, so really abstracting out sort of what are the key components, what are the similarities, what are the differences, what is the detail to focus on in the problem, and then algorithmic design, which is another beautiful word that is slightly terrifying to some teachers as well, because it just reminds them of maths and sounds really scary, but algorithmic design is really just step-by-step strategy of how you're going to solve the problem, and it's a very ordered thing. So when you think about computational thinking, I think one of the things that what we really need to focus on is that it's not just about computer science and coding and computers, although it is foundational to sort of starting that journey and learning about computer science and becoming, maybe a computer scientist, but it's actually a pretty foundational concept for any discipline. So that kind of starts to answer the question. The next question that you had about why is it important? I think it's really, really important because we, in Australia, in New Zealand, and certainly in every other country around the world, where the big high-level picture is we're undergoing a massive amount of rapid economic transformation in all of our countries, and we really need to be producing students and people that are great at solving complex problems and breaking them down to the simplest elements and finding solutions. And that's not just in the computer science field, but it's in agriculture, it's in medicine, it's in commerce, it's in absolutely every single discipline that you can imagine. So I think what's really cool about computational thinking is, yes, it has the scientific sort of application, and it can really be something that can send students off into a fantastic career in computer science, but it's really foundational for people that are working in in music, in arts, in really any industry with the problems that you're trying to solve, because it helps you think about how, really analytically about how to break a problem down, something that's really, really complex, and what are all the moving pieces of it, and thinking about how to structure that in a way for a solution. So it's an awesome skill to learn, and it's really cross-disciplinary in nature in how you can actually engage people with computational thinking in the classroom and things like that. But my number one thing on this is it's not scary, but it's really awesome, and it's a foundational skill for everybody.
Awesome. Thanks for that, Sally. I like how you touched on how it's not just about developing computer applications, which it seems to be most people's first preconceived notion of computational thinking. And hopefully tonight we can explore how it actually does support problem solving and what that looks like at the different age levels in school, and how it can be employed in different key learning areas. So we've got some great people who can probably answer some of those questions here in the panel. So I thought we'd actually jump over to Rebecca if you're ready for your question of the eve. So we've got Dr. Rebecca Vivian from Adelaide joining us. Thank you, Rebecca. My question for you was, what computational thinking courses and professional development are available for educators at the moment? I suppose we're talking predominantly to a New Zealand audience here, but anywhere, Australia, what's available for us as teachers?
Yeah, well, there's quite a lot happening in this space, and I think it's definitely an area that's growing. I've got a few suggestions that can be I guess for any teachers all over the world, or I found a few that might appeal to New Zealand educators as well. So what I might do is actually throw up a document that I've got, which I'll share with you as well, so you'll be able to access this. Okay, so let's go. So what I've got here is I've just put together a document, and I'll just talk through and sort of showcase some of these examples. So I'm from the CSER digital technologies MOOCs that have been created by our group here, and what we've done is we've actually created a series of courses that are designed for teachers to help them bring computational thinking into the classroom. And what we've done with this course is we've not focused solely on coding or robotics or something specific like that, but we've taken a broad approach to sort of introduce teachers to key concepts and think about ways that they can integrate the digital technologies curriculum into their classroom. But I think we've designed it mapping explicitly to the digital technologies learning area, but anyone from New Zealand or around the world are welcome to join, and I think the discussions taking place in our community and the ideas being generated there are really applicable to anyone. And this course is a self-paced course, so we've actually got a few different courses here. We've got ones around foundation to year 6 levels, so starting from the very first years of school, teachers look at introducing digital technologies, then they move through data and looking at how we use data to solve problems, and then they look at digital systems, and then they sort of start to get stuck into the visual programming side of activities as well. But we've also got some for the older year levels, so we've got years 7 to 8 MOOC, and this one takes a project-based approach, so teachers start thinking about computational thinking processes, from the very first design phase to evaluating their solutions and what they're creating. So this one, we've got different streams appealing to whatever teachers are looking at integrating into their classroom. So it might be makerspace activities or robotics or creating games and apps. So this course has taken just a little bit of a different approach in that we sort of take teachers through that design and computational thinking process. So these courses are all self-paced and free, and teachers can enroll at any time. And what we've done is we've actually tied it in with a Google Plus community. So you'll see here that we've got a community just full of ideas where teachers are sharing what they're doing in the classroom, or just even what they're thinking about, and a whole heap of resources there too. So even if we're just thinking about computational thinking, so how Sallyann mentioned algorithmic thinking, if you wanted some activities around algorithms, you can simply search in the search box there. And you can see here that we've got a whole heap of ideas around algorithmic thinking and real-world applications that sort of tie into that as well. Okay, so, but also another course that we've created here is Think, Create, Code. So this is, I guess, teachers who are wanting to explore the application of computational thinking. And this course is one where we've introduced computational thinking, but also learning how to code, and it's through creating digital animations and digital images. So just like how Sallyann has said, you know, you can take computational thinking into a whole range of fields. We're showing you how it can be used in creating digital animations and artworks. So that's one that teachers can do, or you could take pieces of this course and bring it into your classroom for students to do. Probably more suited to high school students, but you might pick and choose bits and pieces from that course. So that one's another one that's gone self-paced, so teachers can enroll at any time. And I guess one that's been showcased as a spotlight for this seminar, we've got the Google's Computational Thinking course, and this one's a fantastic way of showing teachers just how computational thinking can be integrated into a whole heap of other learning areas. So Google have actually set this up around the basic concepts around computational thinking. So you've got algorithmic thinking, finding patterns, developing algorithms, and then putting this into practice in the classroom. And what they've done, I really like this one because they've actually shown how it ties into particular subject areas. So you've got humanities and maths and science. And if you're a Google educator, so you use a lot of the Google apps, you actually see the Google people have built this course around using some of those apps and showing how you can put that computational thinking spin on it. So I think that's just a fantastic example, and we'll hear more about that after as well. But I guess I found some other ones. You've got your CS for high school workshops. So this is a great place to start if you're wanting some hands-on experience. And all around the world, we can see here that you've got CS for high school workshops running. But what's great about this, you can actually go and search current programs. So wherever you are, you can just go to this website, csforhighschool.com, current programs, and you can just zoom into your area and actually have a look at what's happening. So here we can see some workshops happening around New Zealand. We've got one in Auckland, and if you click on it, just to the left you can actually go and see, you know, who's running this. We've got Masha, and you can see what the workshops are and when they're running. So I encourage you to jump onto this website and have a look at what's happening in your areas. So we run some here at the University of Adelaide, and I know lots of other educators and universities who are also running workshops to really help teachers. And usually they bring in hands-on experience, so you get to work with the university or experienced educators in looking at resources, but they also give you some information around, you know, what's the big idea and what are the concepts that you're wanting to introduce. So I recommend having a look at that one. But then I've got also, I won't go through them all now, but if they come up in questions, I can show them. But we've got things like online robotics courses. So if you've got those Lego Next or EV3 sitting in your cupboard, you can dust them off and go through this online robotics course. And this one was funded through the CS for High School program, and it's run by Jennifer at the Rowan University as well. But also I just recommend teachers, if they want to get started, have a look at some of the resources that are available online. So you've got Hour of Code, You can run an hour of code in December or any time towards the end of November as well. And just as an educator, I've gone through and done the hour of code of myself, and I think it's a great place to start if you're just wanting to be, gently introduced to some of those concepts around computational thinking. The hour of code workshop materials are great because they actually have little videos embedded, so you can learn a little bit about, what is algorithmic thinking, or what is code and what is instruction. So you can go through these little videos and then put it into practice by having a little try at some coding as well. So that's a good one. You don't need any knowledge to run an hour of code, so I think that's a great place to start and to get some feedback around your own practice in this space. And then New Zealanders, you're very lucky. You've got Tim Bell from the University of Canterbury. And he's doing fantastic work and has built a whole suite of resources around CS Unplugged. So we just have a look at this. He's got here a book, activities, and a lot of the CS for high school programs, they usually bring in these materials into the sessions. And this is a really nice place just to explore and try some things out yourself. And he's also paired that with a computer science field guide. So we've got the link in there. And this is designed for students, but as an educator, I find this really useful just to go through and learn about some of the concepts. And as you can see here, you can just interact with the web page. So you've got some videos that explain some of the concepts, and then you've got more information and activities as well where you can give some of these a try. And just like this webinar, which is fantastic, I'm so happy that the GEG New Zealand team started this, but you'll start to notice some of these webinars slowly emerge, and it's a great place to connect and sort of see some ideas. So we've got a GAFE and coding webinar, which was run with myself and Chris Hart, and that sort of explores some coding and computational thinking. I've put the link in into the URL for the YouTube video, and that's being recorded and you can play that at any time. But we've also got another webinar coming up for the hour of code. So myself and some educators, Jackie Child and Meridith, they're joining me for an information session on an hour of code. So we're going to go through how you can get started, how would you run one in the classroom, what might it look like, and sort of building in a few ideas for the early years, the secondary students, and even if you're wanting to run one for a library or an organisation, we'll have some information around that as well. So I think these are great places to go if you can find these webinars and look into them just like you are right now. I think this is a great place just to start accumulating some ideas. But also through our MOOCs, I just want to finish on, we've actually noticed a lot of teachers driving their own professional learning opportunities. So what they've been doing is taking some of these resources, maybe CS Unplugged or some of our MOOC activities, and they're actually building their own little PD sessions. So, we've heard about them starting before school, after school, or even on, your PD days. And this is a great place, great way to sort of take that grassroots, community-driven approach into your own hands and tailor your professional learning to meet your context as well. So I'll share that out. I can see some of you sort of jumping on now, but I'm happy to come back and talk through any of these courses and resources to help through your professional learning. So just let me know if you've got any questions around that.
Wow, that was awesome. Huge amount of amazing information. This will be linked as well in the event description, guys, for this hangout for tonight. If you want to find some of those resources, you covered some amazing courses. I know a lot of my colleagues actually have participated in the CSER digital technologies, and actually particularly the CS for HS. One of my guys, one of my ed techs, Matt Harrison, who I poached from a local school here recently, he was telling me that that was the PD he did with that last year in Auckland at Unitech, I think it was the best that he'd ever had. So it was quite a great review of that piece of professional development. I think we'll talk later about Hour of Code as well. There's a lot in that that we could unpack. And definitely the CS Unplugged is an amazing resource for educators. As we've been talking about the CT course with Google, we've actually got James Robson from Forest Hill School here with us. Hi, James.
How are you?
Good, mate. And James is actually on the course or recently participated in the course?
Yeah.
So my question for you, James, is can you share your experience of the course? What were the benefits and maybe what were some of the challenges that you faced?
Yeah, okay. There are lots. By the way, Rebecca, that was awesome. All those resources are amazing. I've been looking for a while, but I haven't found half of those things, so that was great. I went into the course because I'd mainly been looking at CT through Scratch, and I've spent a lot of years programming in Scratch and working with kids with Scratch. And Mitch Resnick and Karen Brenner have worked a lot in developing a framework for CT. What I've tended to do is I'll give the children a theme and we'll develop projects around those themes, and we usually start off with animations and we might go into storytelling, something like that, and then progress into game making. And there's lots of CT skills that come into all of that. But I wanted to refine my teaching practice a little bit by sort of understanding that framework a little bit better, and I thought given this opportunity to do the Google course, I'd get a really good understanding and overview from it. It probably led to more questions than anything else. It's a very broad course. It covers, I think, as Rebecca mentioned, it covers a huge amount of things. So I went away thinking, what is computational thinking? But it broadened my picture of what it is and how it can be used and how it is used. So I started off doing this course. I went through all the aspects of it, and there's some really good little models that you can go into and try out. There's a little logo activity you can do, which I was familiar with, being sort of started out with logo, moved into Scratch. And there is a whole bunch of other things that you can do which are really quite interesting and useful. But at the end of that, you have to do a project and present something that can be used with children in the classroom. It was a bit of a head scratch for me what to do, so I kind of thought about doing something a little bit Richard Feynman-like, some sort of tinkering, exploratory investigation type of thing, and I thought that surely you've got to bring in some computational thinking skills in there. So I started out just thinking a few ideas, and I thought I've got to keep it simple. I want to be able to use it with primary children. So I thought back to some of the things. Actually, my daughter inspired me with this really because she was crazy about staircases. So that somehow sprung to mind, and I thought, oh, well, why don't I look at staircases? So I looked at a staircase pattern, a simple pattern like if you've got 3 in the bottom row, you've got 2, then 1, and it's a progressional staircase going up, 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 up. And I thought, well, I should be able to extract the maths from that pretty easy. But my maths ability is not that fantastic, so when I started trying to do it, it sort of led down a lot of different pathways. I'm just going to wonder whether I should share this on the screen or not. A lot of it's words. Anyway, so I thought first I got to think about what's immediately obvious. So I looked at it, it's just adding a block each time. And then I started trying to extrapolate the maths out of it. I looked at the sequence, I put it into tables. It's really like a pure maths investigation. And the upshot of it was I got 2 algorithms that sort of worked. One algorithm did positives, one algorithm did negatives, and I thought, well, I've got something that kind of worked. So one night after school, one of my students, ex-students who's at high school now, guess year 11 or 12, and he's quite good on maths, and I thought I'd get him to have a look at it, see if he can help me out. And we came up, the long story short is eventually we came up with a algorithm that worked. So I thought that's half of what I wanted to do, and then I wanted to show how could I use that algorithm to show that it actually made the stairs. So I used that algorithm in a Scratch program, which I'll put up on the screen in a minute. See if I can find the screen sharing. And that basically, it was interesting really, because usually I would start with like a theme or a project with children. This time I started off with investigating something in real life, pulled the maths out of it, and then put it into a program. So I'll just quickly show you that. So this is the program. Show it to you on a. So the can I scroll up? I'm scrolling the wrong screen. So you put in the number of blocks you want. Let's say I put in 10 here. And the cat asks the question and gives you the answer, and there's a little mouse that draws the blocks, and it'll draw the staircase for you. And I chucked this bear in who also tells you about the ratios and calculates ratios and other bits and pieces. I'll show you the inside of that. So this is what the cat part looks like. And this is where I've put the algorithm in here. And I actually found it a whole heap easier doing it this way, actually working the maths out first and then working on the program, rather than trying to work out the program and then try and work and then find the maths. Just a different way of working. And the little mouse does the drawing parts, so the pen up, pen down. It's also defined, I did a few different things that I wouldn't normally do in class, so I sort of, as my own investigation, sort of played around with it as well. I'll just take that off now. I will put this up to share at some point if people want to have a look at it. So the other thing I'd like to share with you is just that, that Scratch Ed is a good resource for looking at computational thinking. There's 3 webinars that Mitch Resnick and Karen Brenner do in Scratch Ed that cover their thinking around and their framework for computational thinking. The first one's about concepts of programming. So they talk about sequencing, loops, events, conditions, operators, variables, lists, and the things that you would do in Scratch. And then the second webinar is on the practices, like testing and debugging, that kind of thing. Reusing and remixing is a big thing in Scratch, where the kids get to see someone else's code and then play around with it, take parts out, use parts in theirs, that sort of thing. Being incremental and iterative, so doing loops, that sort of thing. And then the third webinar is about perspectives, and it's about expressing, connecting, and questioning. So that's well worth looking at. It explains it really clearly, and they've also got a website with that laid out nicely so you can look at it, and it also talks about how you see that happening in children's work, and they've got little examples of that as well. So I will put that up at some point and share those resources with people. That's probably about it for me.
Thanks, James. That was great, mate. I love those hands-on examples of what it looks like in practice. And yeah, I'm a fan of Scratch as well, and that Scratch Ed is a great resource. So thanks for that. I'll cross over now to Meridith. Hi, Meridith. Meridith is the e-learning specialist and innovation integrator at St. Columba Anglican School, and she works with the Professional Excellence and Innovation Centre as well. I must admit she's an old colleague of mine, poor Meridith, and she does some amazing stuff with computational thinking. You guys recently ran a conference on computational thinking, Meridith?
Yeah, we were actually one of the 2 schools in Australia to get a CS for HS grant, so we were really excited to get that, and we used it to run a conference, a low-cost conference for teachers. So we ran 2 for 1. Rebecca was actually one of our keynotes, and it was the best learning experience. My only disappointment was I didn't get to go to the workshops. So I got lots of resources, but I missed out on the things I wanted to go to. I was too busy organising. But it was a really great resource and a really great thing because we're mid-north coast, so we're 4 hours north of Sydney, and it saved our school and all the local teachers a lot of money to be able to come to a local conference that had really high caliber speakers and workshops run by a whole range of different people on different topics: Minecraft, visual coding, robotics, B-bots. We did lots of things. There was a session on the Adelaide University MOOC, just lots and lots of things that a lot of teachers had never heard. And I was a fly on the wall in a lot of workshops, and I heard our staff go, "Ah, that's why we would do that." So it was worth everything because all of a sudden other people were saying the same things as what I say, and it really was like a light bulb moment for a lot of teachers.
I'm actually really disappointed that I couldn't be there. I was
about a term too late.
I know, I'd crossed the ditch by that point. So my question for you, Meridith, is can you share with us your experience of integrating computational thinking into the curriculum and teaching practice?
So being in New South Wales doesn't have the Australian curriculum. So the Australian curriculum for New Zealanders has integrated coding into the actual curriculum, and New South Wales has not gone down that path. So we've had to get clever. So what I've done is integrate coding and computational thinking into other curriculum areas. So, for example, on and offline. So I started teaching coding about 5 years ago, before even Australian curriculum was released, and integrated it then into narratives because I had to justify to curriculum coordinators in the school and why I would teach it and what other outcomes I was teaching. So we incorporated it into gaming and writing narratives, and then everyone made games using a Microsoft product. It was a free download called Kodu, and so we downloaded that, and then it's visual programming, and it was before I discovered Scratch. It was the only thing I knew of. So they wrote stories using programming games, basically. And then from there we went on. I've just built on it, and I then did Rebecca's MOOC, and from there it's just been one wild ride. So I now integrate it into maths. We do a product called Pencil Code. So all of these products that I use are on my website, which I'll screen share in a minute. So I use a product called Pencil Code, which is really a fancy logo, and it's visual coding, and you also have the option of text-based coding. So as you get older, you can actually start to introduce the text base for older students, and then you can. We did angles, and we've done symmetry and 2D shapes. Start to talk about 3D shapes and drawing 3D shapes. Once you get into secondary, there's actually examples of fractals and all sorts of different and quite complicated programming options. You've also got music. You can compose music using it, which is a great way to engage, I think, girls, because I think girls are often not engaged, and that is something that I've actually become quite passionate about, is trying to encourage girls. I find they start to drop off interest-wise in about year 6, and I am struggling to get them to return. So you need to find things they are interested in. And so the release of things like the Frozen product in Tinker, is it Tinker or Code.org, has Frozen as a game theme, and that actually the girls love it. So it's a really great way to rather than just always having, you know, racing games and games that would engage boys. You've got some themes that are great for girls as well. So that's maths. You can also integrate offline. You can integrate your computational thinking into your maths in data and surveys and data and manipulation of data in graphing and things like that. I find I think the weakness for a lot of teachers is thinking of the application to make it real world and not be contrived, like eye colour. So it's about really, that's the difficulty. I think that's where the problem teachers have with this is, I want to do it, but what can I do it with? So that's offline is data manipulation is really a great tool. Last time I did computational thinking with you too, so it's not even just primary and secondary. You can do it with K1 too also. So what we did was we worked out how to draw a square using a procedure, and then we went outside and we mapped around the outside of the playground, which was coincidentally a rectangle. And then we came inside, and then we proceeded to go on to Blockly, where we talked about directions, left, right, angles, and I just did direct instruction. This is a right angle, and it's 90 degrees. And I wrote it on the board, and they were great with it, even though it's an outcome that is above a 6-year-old or 7-year-old level. It's something that you can teach in a moment that it's relevant. And I think one of the difficulties for teachers, if you are teaching programming, is that some of the concepts you're teaching are actually beyond the educational outcomes for that year level. So for me, teaching pencil code to year 4 is when we do circular geometry, they have to then know that there's 360 degrees in a circle and what is a 180 degrees, and those sorts of things aren't required in Australian curriculum or New South Wales curriculum until years 5 and 6. So I actually have to dumb down my educational outcomes to fit in with the curriculum, because I think computational thinking and coding just takes learning to a whole new level. So with regard to that, I would just identify the outcome that best reflects what you have to teach, and if it goes beyond that, big cheers in the classroom. So that's how I deal with it.
Awesome. Thanks, Meridith.
Okay.
You've touched on numerous great things as well. And I've been in some of those coding sessions you were running with the girls, which were amazing. Something you touched on, which I think was really a great point that actually Rebecca was messaging us about earlier, was real-world investigations. Did you want to touch on that further? Anyone? Rebecca, anyone?
I've got an example.
Yep.
So that is actually my biggest struggle, is making it real, because once you get it something that's real, it then becomes something they can learn from. So what we did with a science unit I did recently on solar system was we mapped the solar system to the size of 100 metres. But the first thing I did was I got them to measure the football field and work out how long the football field was with trundle wheels. And they came up with all great ways to find it out, ask somebody and Google it. And I said, well, we can do that if you want, or do you want to go and use the trundle wheels? And of course we were out measuring. So we did that. Then we went back in the classroom, and I didn't give them direct instruction on how to do it. I just said, I need you to do to work out how big the solar system is. So we came across astronomical units, which incidentally I didn't know what an astronomical unit was before this unit of work. So it just, you know, teachers, I suppose, need to go to that place where they didn't know something before and go with it. Ultimately, we plotted the solar system onto the back oval and then flew the drone over the top. Thanks, Matt, for buying that for the school. That's fantastic.
I missed that drone.
So flew the drone over the top, and what happened was you can really see the clustering of the planets close to the sun and then the distance with the other planets as they get further away. And it really brought home when we discussed it how big the solar system was. And it was even something that I was a bit overwhelmed by, that's on 100 meters. How big is the universe? And so that was a really interesting application to the solar system. And do you want me to talk about my remote control lawnmower?
Oh, you'll make me too jealous if we go on about the toys.
I got a remote control table too. That was out of Year 8 boys. He needed it to pass the chips across the lounge room, so he didn't have to get up. And it works with the TV remote.
True innovation for a purpose. So, Sally, why is real world investigations? Why are they important?
Yeah, look, I really, this is something I'm incredibly passionate about, and I really wanted to address this because I think sometimes we think that real-world applications are for when kids are older and they're in high school and thinking about university. But the reality is we have an absolute skills gap in both Australia and New Zealand around STEM skills, and particularly technology skills and computer science skills. And we don't have a good representation of women and other underrepresented groups, Indigenous communities and people like that in the industry. And the latest research and studies show that these groups in particular are disengaging at kindergarten. And it's lower than grade 5. They are really opting out of things. And part of the reason that they're opting out of things is because they don't understand the application of it. You know, there's a lot of people that don't want to become computer scientists and programmers, and that's completely okay. But they don't understand how computational thinking or how technology or how science and maths really can connect to the real world. So I think, you know, creating the unit of work, and I love that example, Meridith, of what you've just done. I'm just like, oh, God, I want to go back to school and like be in your primary school class because that is just awesome. But I think it's just sometimes about framing the work that you want to do and going, well, what would be the real world problem that we are solving? Kids are really aware of the challenges that we're facing in life. You know, they know that global warming is an issue. They understand that, you know, there's wars, there's challenges that we're facing around refugees. Kids, even very, very young, understand some of the context of that. So framing some of what we do and why we do it in those social sort of side of things and some of the problems and challenges that we're facing really helps them make that vital connection, I think, between a real-world problem and skills, technical skills that are going to be part of the solutions to those problems. And I think sometimes we miss that gap. It's not a huge layer that I think needs to necessarily be added to everything that's done in the classroom, but it's one of those things that really helps kids, you know, it helps them understand the link, and thinking about that really, really early, it can help potentially, you know, that they won't self-select out of technology or out of science or out of maths. Because let's face it, I remember doing maths at school and I did advanced maths and I could never understand where I was ever going to use that in life, because no one could sort of say, well, this is how you would use it. But sometimes when you say, oh, we're going to build this technical solution or we're going to build a product to solve this problem, that becomes very, very real. And then you go, okay, well, why do I have to understand that angle, and why does distance matter, and what are those units? And you know, that's where it becomes a really interesting problem. So thinking about what Meridith just said, you know, I've just come back from holidays, and one of the things that I did while I was away, I read that book that the movie's just come out about Matt Damon going to Mars, The Martian. Great book, right? But I can imagine that kids, that movie comes out, what an awesome opportunity to say, well, why would it matter that you can understand the distance and calculate distance between planets and things like that? Hypothetically, you know, you could put that in the context of putting somebody on the moon, making somebody go to Mars, you know, all of those kind of things. And then it becomes something that's like, it's not just abstract. It really is something that, oh, there's people that do this stuff around the world and actually do that. So I think that's really, really important. And particularly, for, as I say, for those populations that are disengaged, making it really, thinking about how do I make that culturally relevant to them? Is there something that would be applicable to just tie a little bit of a narrative in so that they might be hooked into engaging with this a little bit deeper? And sometimes we miss doing that a little bit, I think. So that was, sorry, that was a very long comment, but I do think it's really important for us to.
That summed up the why really well. Rebecca, do you have anything else you'd like to add?
Yeah, probably just an activity building on that if you're wanting to run PL sessions or even just think about real-world examples. One of the very first activities we get teachers to do in our MOOC is to actually go online and look at, say, news articles around technology, or look at the Careers with Code guide. I've just thrown that into the document I'm sharing. But you know, do a search, look for technology plus fashion, or technology and science, and technology and sustainability, or computer science, and sort of see what other people are doing to solve these challenges using computational thinking and code. And so even just in our community, so the F2 community I've linked in the Google Doc, if you just go to the first task, Introduction 1, you can see all the examples that people are sharing. They're finding things where people are using data from drones to track wildlife and to solve some really, really big problems. So I think just even go on and have a look and trying to bring those into the classroom. So if you're teaching around a science topic or in maths, try and see if you can pick some of those examples, show them a news article or a video, and just try and bring those examples in, I think.
Yeah, they're great examples. I know one of our students on our postgrad course we run at the Mind Lab, she's Fee from Taupo. She's created, or her kids have created, I should say, stoat traps. So for the Australians, we've got things over here in New Zealand called stoats, and they run around in the wilderness. And they've got stoat traps they've created, and the kids have created like a QR code scanner system for the top, so that when bushwalkers come across a stoat, they just can scan it with their phone and it gets shot off straight to the kids in the classroom. I think that's a great real-world example with a good social and environmental impact. I think always bring it back to the why is so important with these topics that can seem so nebulous and dry on first appraisal. You guys have raised some amazing things tonight, and we've encouraged our viewers tonight to ask questions. And we had a question come through from Andy Escrow on Twitter earlier, asking where else could we extract maths from and apply to programming? Anyone want to dare to answer that question?
What year group, Matt? Does it say?
It doesn't say. All I've got through from Anne Batchelor, who's running Twitter for us, is where else could we extract maths from and apply it to programming? So I'm thinking this is probably like another real-world example of how to utilize mathematics and bringing it into part of the computational thinking learning experience. Have we got any maths examples, guys?
Yeah, I could probably build on what Meridith was talking about, and I guess not knowing the year level, from the very first early years, students can just build language around algorithmic thinking, which ties into maths. So you've got your navigational language, positional movement, so forward, left, right, and then moving on, you can build in geometry, so looking at how shapes are created, and so using what Meridith says to, you know, instead of getting students just to draw shapes on paper or use geoboards, you might complement that with getting them to actually create shapes using code in pencil code, or even in the older years, building in things like Think, Create, Code using processing.org. You can actually get students to think quite advanced around geometry and shapes and you know, how things sort of work together. And also even just combining data. So data is a huge part of coding and how you can use that to solve problems. So Linda McIver, she's a teacher, and she actually goes out and actually sources real-world data sources from local businesses or researchers, and she has her students trying to use code to analyze it, so thinking of algorithms to visualize data, and they've even gone on to create an app so that businesses, instead of manually collecting data, they can just enter it straight in online and visualize that.
Awesome.
Yeah.
Thanks for that, Rebecca. We've got another question from Mike Buckham, who wants to know, should STEM or STEAM not be STEAMs, science, tech, engineering, arts, maths, social? Without the social, where is the why? Real-world examples, problems are social in nature, effect, as are the solutions. Comments, anyone?
Yes. This is my... I'm jumping all over this one because this is my pet. This is something I'm really passionate about. So I'm going to be maybe a little bit controversial. I don't think we should use STEAM or STEM or STEMs. And the reason for that, I think, is if I work for Google. I work, you would say, at the bleeding edge of where the future is, not just in technology, but in a large sort of in an ever increasing multidisciplinary sort of space, because we're part of Alphabet now. And I think one of the ways that we like to frame this conversation is a little bit different. Rather than focusing on 4 or 5 disciplines in the social context, we like to talk about CS plus X. So computer science plus X. I think an X can be any discipline, the problem that you're trying to solve, or your passion. So let me give you a couple of examples to kind of make this a little bit tangible of what I'm talking about here. With the caveat of what we're saying is that we're in a digital economy, in a digital world, and computational thinking and computer science is going to be at the center of everything we do. Whether we're coding or not, we're certainly using it, every day, from the computer in my pocket that I have, that we all have now, to, our TVs at home, our smart TVs, our, self-driving cars when we get them. Everything is going to be very much digitally driven and have a strong computer science foundation. But, for example, CS plus medicine could lead to, or has led to, such developments as Iris. It's a smart contact lens that you can wear in your eye, automatically detects from the Sallyann in your eye your blood glucose levels, and sends alerts to your smartphone and helps you manage your diabetes. And, or CS plus medicine could be somebody that goes to the Sudan and prints 3D prosthetic limbs and teaches others how to do it as a low-cost way of absolutely changing the quality of life of people there. CS plus music leads to these insane and incredible performance artists that I just saw when I was at the Grace Hopper conference in the US, where they've combined digital technology that is interactive and moves with the beat and a whole stream of dancers and computer science to create an entirely new form of art and performance art. The list is endless. And, one of the links that I'm pretty sure will be in Rebecca's document, because I know she talks about everything I want to talk about, is the Careers with Code guide that we've helped develop to kind of really try and drive that conversation that it's not about becoming a programmer or computer science, and it's not about becoming an artist, and it's not becoming about a doctor or a lawyer or an accountant. Really, the future and the careers that kids that are growing up today are going to have are not going to be single focused. They're going to be multidisciplinary in nature, and we really need to be as inclusive as possible. So personally, I don't use STEAM. I don't use STEM. I won't use STEAMs. CS plus X is the narrative that we use all the way, and try and because it really does mean that if your passion is art or music or photography or social causes or social justice, whatever it is, you can make that foundational with computer science and really build out something that is going to change the world.
Awesome. Thanks for that, Sally. So we've got 5 minutes left, guys. So is there anything anyone has a burning desire to share before the end of the session?
I just wanted to add, like we're talking about science a lot, and I agree, we need to think about arts and music and that sort of thing as well. A lot of the stuff I do is based on storytelling, but when you start building a story in scratch, all the maths and everything that comes into it is right there. You don't have to start with maths necessarily. It's in the programming and the procedures and the things that you do to make other things happen. And the other thing we haven't touched on a lot is, I think, sharing what you do. One of the powerful things I've done with students is we've created a program to talk about ourselves and where we live, things that we do, and share them around with other cultures. So we've done a lot of global sharing, and that I think is a really good motivator for children, that they know there is their purpose for their project is to share with someone else, and they're part of a collaborative experience. And the other thing I'd like to touch on as well is something we talk about, programming to learn. And I had some kids doing some Year 1 students programming Scratch Junior, and they were creating a program that they chose sprites to show up in a certain pattern on the screen, and on the other side you had to click on the number that was represented in this pattern, and they were going to take that to the new entrant room to get the new entrant children to do their game. So, and in that respect, the children are recognising the pattern, the number pattern on there, and then recognising the number to match it. But the older children had the opportunity to actually build that program and understand how it all tied in.
Awesome. Thanks, mate. Well, this session's been great, guys. I really feel like we've gotten to the essence of the why with computational thinking, and probably shed some light on not only how important it is, but how exciting it can be. And I think that's important for teachers trying to do this, is to find their why and find their passion with this, because I think that really drives these projects that we're all running. Thank you so much, guys, for your time tonight. Wherever you are, across the ditch or here in New Zealand. Does anyone want to share anything before we stop broadcast tonight? Great. All right. Thanks, everyone, and we'll see you next time.